Okay.
All right, so we've got KIN 499. We've got graduate student Jesse Klingman, who's going to talk with us about the Myontec shorts. I hope I'm saying it right still. This is the EMG, and I posted some information on our 499 Canvas page about EMG basics, and that's in essence what these shorts are supposed to do. So Jesse, I'm going to turn it over to you to give a demonstration in how that works. Okay, now hold on. Who is Original Lay's Chips who just logged in? You can type in your chat. I'm just keeping track of who's on.
I'll combine them too. So you can record directly on the slides.
Okay, I'm gonna say, okay, go ahead, Jesse.
Okay, so just to start this out, I would recommend whatever Dr. Mercer has posted, definitely read it. Even at the graduate level, you have certain people that dive into EMG and they don't truly know some of the limits effectively used for. I know Dr. Mercer has good articles on that too, so if you're interested in it, make sure you ask him about it. So to start out, I just want to show you guys, let me see if I can, this is my first time zooming on my phone, so I got to flip my camera. Okay, so this is what a typical EMG sensor looks like. Okay, this is one of the Delsis EMG sensors here in the lab. Okay, so usually when we do surface EMG, we connect these electrodes onto this EMG sensor, and you can kind of get an idea for the size of it. Okay, and then a lot of the times once you get it, the process is a little bit harder where you have to shave the skin. You don't want hair where you're going to be measuring over the top of that muscle belly. We usually wipe down the skin with an abrasive ice, and then we got to secure the sensors on with something like this. I mean, I think people do it a little bit differently, but so far since I've been here, this has been the Swiss Army knife for EMG that I've seen. So that's just to kind of give you a traditional sense of what like surface EMG might look like. I didn't know if Dr. Mercer had given you guys something to look at like that. So that's your original sensor. And you can kind of see when we use this, we're going to be trying to measure one muscle in particular. Okay. So that's important to note because that is a big difference between the shorts. And I'll just say this right off the bat so that I don't forget to say it. If you're interested in reading more research on this, Textile Emg is what you would want to type in wherever you're doing your primary source searches. Okay. So there are a couple of different companies that do Textile Emg. This just happens to be the one we have. Okay. Myontec, like Dr. Mercer said, I think that's right. So I want to show you guys the sensors. Okay, so these are actually the EMG sensors in the shorts. So with the way this is oriented, these sensors back here are going to be measuring the hamstrings, right? This is on the other side, and these are the inside of the shorts. Okay, so this is on the other side. These sensors would be measuring the quads. And then we have sensors up here to measure the glutes, okay? So obviously right away, one of the things you can tell is the way this is different from traditional surface EMG is they're measuring like functional muscle groups, right? Like there's a couple of muscles involved in the quads. There's several glute muscles, right? So these have a lot bigger area of where they're kind of capturing that electrical signal. Okay, so that's kind of important to know. Another thing that's super important to start off with and talk about is obviously the fit of the shorts is very, very important, right? Keeping these sensors in contact with the skin is key in getting good data, right? So if you're wearing a short that's too big and the sensor keeps coming off, probably not going to get great data. So also just keep that in mind while you're using this. So obviously where you can see this type of Textile EMG's purpose is going to be more for live, like real-time data collection, right? Like it'll be a little bit tougher like to leave the lab with surface EMG. You can do it, but it's a little bit tougher to leave the lab and have your normal mechanics with whatever sport you're trying to do if you have a bunch of these sensors attached to you, right? Whereas with the shorts, you can throw the shorts on and go out and do whatever your activity is. I know that we here are probably going to do quite a bit with cycling, but there are a few options for what you can wear this for, what sport you're doing, and like you can, it's not just for cycling or running or whatever. And I'll show you some of the options you can pick here. But so that's the shorts inside out. Okay. Another huge component of this or thing for this is it's washable, right? Textile Emg. There's another bag that I can throw this in. I can throw this in a normal washer, like a clothes washer. There's some settings I obviously have to be careful with, and I can just wash these in between uses, right? So that's kind of cool. The next component of this we need to talk about is this M cell. Okay, so this M cell is what allows the shorts and the signal that they're collecting to communicate with the computer. Okay, so and the M cell depends on like what you can do, how you can interface with their app depends on the M cell you have. Okay, so we have what's called a traditional M cell. So we can't run the app, like we can't do a live look at the signals that are being connected on an iPhone. We have to do it on a laptop. Whereas if we had a smart M cell, then we could do it, like you could literally be training, running, cycling, doing whatever you're doing, and getting a live look on your phone of some of your muscle activation, right? So this is what I mean by real time. The idea is you can make certain adjustments while you're training with these arms. So this is important. This is how it communicates with the app, so that you can actually watch your muscle activation, or sorry, I guess I got to be careful how I say that, but watch the data that's coming through. Okay, so the M cell, these go on the front of the shorts. Okay, you connect the M cell in here and you'll see the light start to blink blue. Okay, another important thing is when you go to put the shorts on, they ask that you give the textile electrodes on the inside a couple of spritz of water. Okay, and then obviously we want the electrodes to be in contact with the skin. So if you want good glute activation, you're not going to wear anything underneath these, right? Like we need to be in contact with the skin. So that's another good thing about the fact that these are washable, is because we kind of got to put it on so we can get right on top of the skin. Okay, so I'm going to flip this camera around so you guys can kind of see the app itself. Let's see. Okay. So here's a look at the dashboard on the app. I'll see if I can get it so that there isn't glare so that you guys can actually see what's going on over here. I don't know if that looks any better. You can just see me. Okay. But here's what the app looks like. Okay. So when you first get here, you just have this screen. Okay. And you can see my name is attached to this right now just because I'm the one that activated the product code. But if you want to measure, you go to measure. Okay. And right now the trainee that it's on is me, but we can go here and add a new trainee. Okay. So there I am. And then there's Ted Gerard. Okay. So we can add a new trainee and it gives you an option. You can put in your birthday, some of your anthropometrics, right? Like weight, height, all that stuff. And then anyway, so once you get the data that you want, or the trainee that you want selected and you get them inputted, you go to measure. Okay. Another really cool thing about this is you can simultaneously, you can pair a heart rate monitor and a power meter. I don't know if you can see that, a power meter with this app. So I can collect surface EMG, textile EMG, simultaneously with heart rate and power to give myself an even better look at training. And that's kind of the main thing that these shorts were advertised as being great for, was training. Okay. And then, so right here we have this exercise. So you can see when I click on it, it gives me this drop down menu of all these different types of exercises. Okay. So mountain biking, triathlon, football, weights, cross-country skiing, ice hockey, gym. Okay. And you can customize a couple over here. So really cool. You can really personalize this, and building on the fact that it's for training over here, you can see, you can set training zones. Okay. So what this app does is it can help you determine what's called your muscle fatigue threshold. Okay. So what one of the things that EMG can pretty reliably be used for is the fatigue index, right? So there's a lot of things that contribute to fatigue, but it can pretty effectively be used for fatigue. And another, building on that, you cannot make comparison with these shorts between subjects. Okay, so whatever readings I'm getting for myself, I can't compare that to another person. Okay, and they actually explicitly state that in their user guide. They kind of make that very clear, and they have a really good user guide. Lots of good information, explanations, and they actually have quite a bit of YouTube videos or tutorial videos that are actually super helpful too. So if you're ever interested in working with this, it's pretty easy to find some good resources. Okay. So anyway, really good for training, and you can select the training, the zone that you specifically want to train in right here. Okay. Obviously you would have to do some pre-testing before you selected your zone, right? So that it could kind of get those values figured out for you. But once you have selected, like, let's just say we're going to do a run. Okay. I can go to my interface view, and they have what's called a research view and a live view. Okay. That just depends on how you want to see the data displayed. And you can even set laps so that it knows I'm working at my muscle fatigue threshold, or I just want to go for a certain time, or whatever it is. Okay. Then this here is where you select that target zone that we were talking about. I want to do some zone 1 training or zone 2 training. And it defines those zones over there like I've showed you. But once you've got this all selected, you press start and it'll start collecting. Okay. Now, if I had the shorts on, or if I had somebody else that had the shorts on, I would jump into that. But the good news is we do have some data that was collected on me a while ago. So we'll just click on that. So if we go back to this left side where the measure was, and we click on data, you can see these files, a list of the files comes up. Okay. And then this is kind of like a snapshot of this, of the data taken from this particular workout. Okay. So you can see that it was about 8 minutes long. I was running. This little schematic kind of gives you an idea of activation based on each muscle group. So according to this, my right quad group was actually it was quite a bit more activated than my left quad. My left hamstring and right hamstring were pretty symmetrical. And then the glutes were pretty different on both sides, with my left glute being a little bit more active. Okay. So that's another pitch point for this, is that you can see asymmetries and hopefully make some adjustments to your technique or your mechanics, so that you can essentially get better, right? Training. That's what we're trying to do, is train a little bit better. So I just lost my signals. Normally when I open this up, there's a signal right there. Let me back out of this and see if I can find my signal again. Okay. Open the file. Oh, I don't know why they keep disappearing. No. Hold on just a second. Let me see if I can get this figured out.
This is great information, Jesse.
Thank you. It's really cool when you can see, and obviously if you could get the signal up, I don't know why the signal won't pop up.
You know, just to build on what you said about comparing the signal between people, that's an excellent point. The other challenge that we often are faced with is actually comparing the EMG between muscles. And that's not always easy. So the right quad versus the left quad, the signal that you can get may actually be a little bit different, because of the way the quad is built for the left side and the right side. We're not 100% symmetrical, nor is the electrical activity and the nervous system exactly the same in terms of the wiring of the muscle. And so it ends up being an interesting issue of even comparing between EMG signals between muscles. We do it when we've done it, but we know that we need to be careful with the limitation of that, though.
So I was able to pull up the PDF. For some reason, the live view is kind of giving me some troubles, but you can kind of see it gives you the root mean square of some of this data. And you can tell that it's filtered as it comes in, and the frequency at which the data is sampled and how it is filtered or smooth, it depends on the M cell that you have as well. So this is kind of right now on the graph, that yellow line is just the muscle load. And you can see up here on my key, if I had a heart rate monitor and a power meter, that would also be overlaid so I can get a really good look at some of my training responses. And I can tell you right here, I was obviously just like a nice light, easy jog. I think it was about 5 miles per hour. And then I jumped up to about 8 miles per hour. And I just kind of kept going to see, and I messed with inclines. And this just gives you your average activation. I know that's really small, I'm trying to show you, but like I said, this gives you a really good look at some asymmetries that the shorts may be detecting. Let me see if I can exit out of this now. Escape. Yeah, I don't know. Trying to get.
And while you're doing that, I'll talk a little bit more. So when you look at the signal, the first time you look at an EMG signal, you probably are looking at it and saying, "What the heck is this? It just looks like noise." And you know, in the chat notes, I posted EMG is electromyography, EKG or ECG, whichever one, is electrocardiograph, so electrocardiogram, so electrical activity of the heart. That's what we're most likely familiar with. EEG is electrical activity of the brain. Well, the EKG, which I'm sure you've all seen it, it's very predictable and it's very standard almost between people in terms of the pattern. And that's because of the way the heart and the cardiac muscle behaves, is it's very synchronous in terms of how those muscle fibers are contracting. Whereas a muscle activity, there's thousands of muscle fibers in here and they contract asynchronously. And so what we're seeing, this is not correct, but it's the same idea. We're seeing a lot of little EKGs built on top of each other. So a lot of the muscle fibers are contracting at a different time, motor units, and therefore it often looks like just this squiggly line. It doesn't look like an EKG because the way the heart contracts is much more of a predictable pattern.
So for some reason, the amplitudes will not pop up. I don't understand. I've never ran into this problem, so I guess I'm gonna have to get a hold of support and see what I can get figured out. But so just to kind of, I guess, sum up and touch on some of the important points, the whole idea behind this product is the fact that you can use it for training. So just to build on the muscle fatigue threshold, the idea is it's kind of similar for people that cycle. It's similar to kind of like the functional threshold power. Okay, so it's a point of muscle activity where you can sustain that workload without having to recruit more motor units. So in theory, it's almost like this point where you're exercising and staying at a level that you're going to see adaptations, but you're not going to introduce too much fatigue in theory, right? Obviously stuff needs to be done and research and questions asked, but that's kind of the idea behind the fatigue threshold. Some of the other claims that they make is with this, because you have heart rate and the EMG measures, you can optimize your warm-up, or you can optimize a cool down, or so there's some really cool things that can be looked at with these shorts as far as how to prepare yourself for training and then how to train. Make sure you're looking up Textile Emg if you want to look it up in research. There are, I think when I first looked it up, there's about 3 or 4 brands of different types of Textile Emg. And I think other than, I wish I could get those signals pulled up.
That's all right. That always happens when we do a demonstration. So things
So,
things just automatically break when we have to demonstrate them. And you know,
yeah,
your point is excellent, is that it's not just how active a muscle is, it's how it's coordinating with other muscles and the timing of when the muscle is contracting, again, not only for the movement, but also relative to other muscles. So we think about co-contraction of, you know, muscles, agonist and antagonist contracting at the same time. Well, if you can learn to turn off one muscle one time and another muscle on another time, you can have a movement efficiency, which maybe you end up having less muscle activities. This is part of the trick with understanding muscle activity, is that muscle does not operate in isolation.
right.
That's
Yeah.
great. That's good stuff.
So,
All right, let's open the chat up for questions from folks.
let's see.
And while people type in questions, I can read them, Jesse, if you can't see them, and that's all right. One of the projects that we've talked with Incrediware about is using these shorts under Incrediware, the product. I always forget how to describe this product. It's not compression, but it's the Germanium infused fabric for recovery. And he's interested in whether or not these shorts would allow us to measure any influence that the Incrediware product may have on muscle activity. It's a little tough because if we start looking at muscle activity during recovery, those magnitudes are going to be really low. And just like what you showed in that one data set where you're running different velocities, as you run faster, in general, EMG is going to go up, but until some point. And it's more complicated than just it's going to go up with speed. It's because it's a timing issue and it's a co-contraction issue as well. And so if we're measuring muscle activity during recovery, that's actually hard because the muscle, when not being used, is really quite quiet. All right, got a question. I'm not sure if you touched on this, but would you say that the sensors in the shorts are similar to like a body scan sensor? Oh, interesting. Yeah.
I'm not sure I understand completely a body scan in terms of like what. I guess I need to understand the question a little bit better.
Probably, Lauren, I'm thinking you're thinking like the bioimpedance scale, like the in-body or the Sika that's over the X-Vis. Yeah, or like a
the
DEXA.
DEXA?
Yeah, or DEXA. It's definitely not like DEXA. DEXA is an X-ray machine. It's dual energy X-ray absorption. So it's actually, DEXA is an X-ray of your body. It's just used in a particular way that you can get more granular detail than the way an X-ray works. The in-body and Sika, have you looked at those, Jesse? And
Yep.
how they, okay. Do you want to talk about those a little bit?
Yeah, so the in-body and what they measure basically how fast a really low current is passing through your body so that it can kind of pick up different tissue and cell type in your body, right? So electricity is going to pass through fat at a different speed than muscle, right? So what it does is sends that electrical signal so that you can get an idea of your body composition. Where this is different is the electrical signal that this is picking up. One of the ways to think of it is that the neural drive, right? So when we want to turn a muscle on, that alpha motor unit, it sends a signal down to the muscle and tells the muscles that it innervates to turn on, right? So it's basically like a voltmeter, right? Like it just sits on the skin, and what it's doing is measuring a voltage sent to that muscle, right? One of the ways Myontec words it is kind of saying like it's the internal power output, or it's the neural drive, that what your brain is trying to tell your muscles to do. You have to take some of that stuff with a grain of salt and do a little bit more research on EMG before you can say stuff like that. But kind of like Dr. Mercer said, if you have an understanding of those limitations, it's okay to kind of look into those things and just be a little bit careful about how you word it. So it is measuring an electrical signal, but it's still different from the Sika or the bioelectrical impedance devices.
Oh, perfect. Yep. No, you're spot on with that. And yeah, and to your point on the muscles, is we can only measure surface level muscles. We can't get to any of the deep muscles. And when we are measuring, we're limited to that area, whatever the size of the electrical sensor patch is. And so that's often a challenge, more so with the EMG that we use for our systems is it's just a small little patch that goes on. The shorts are a little bigger patch,
Right.
but still you're limited to measuring the muscle activity in that region as opposed to the entire set of muscles. Great question.
Right.
Thank you.
That's why I brought up the point of the EMG sensor. Traditionally, it usually measures one muscle. For
Yeah.
us to hook these sensors up and measure the same amount of muscle activity or that electrical current that the shorts do, we would have to use quite a few of these sensors compared to just slapping shorts on. So convenience, it's definitely convenience.
Yeah, and we've done some work on the influence of how you put those sensors on the skin in terms of orientation, how far apart they are, and so forth. And you can get a different signal based upon the orientation of putting that patch on the muscle, on the surface.
I remember talking with Dr. Mercer when I first got here about EMG, and we kind of joked. I had a mentor at my previous school that called EMG the dark arts, right? Yeah. EMG is great for a lot of things or some things if you know how to use it, but it can get pretty complex and complicated if you're not sure what you're looking at. So pretty cool.
It's a little bit of, we also call it reading the tea leaves. Not always easy to figure out. And it's important to note that EMG is just a tool to measure muscle activity. There's actually other tools as well. You can actually measure how much the muscle vibrates during a movement. And then you can also stick needles in the muscle and then look at the internal signal. And that's where you can look at deeper muscles in the body. Good. Other questions? Thank you, Lauren. That was good. Jesse, looks like the lab's pretty busy today.
Yeah, we've got Dr. Silvernail and some other kid that you might recognize in here. They're doing something in the Lifetime lab. Let me see if I can flip this camera around.
I think they're packing some stuff up that's not working. Yeah.
Yep.
There you go.
I don't know. They were playing around with that big box, whatever that is.
Oh, wow. Nice.
Oh, there you go. The M-body. They said they're packing up the M-body.
Yeah. Good. Well, thank you, Jesse. That was really a good overview of what those shorts are. And those shorts run about $1,700.
Yeah. Sounds about right.
Yeah. So, yeah, I got to pay the bill, actually. So yeah, it's they're not cheap, but I think this is the idea of smart fabrics is, back in the day, even, the first power meter was well over $1,000 to use for cycling. And now you can get power meters for a couple $100. And so as these devices get refined and the information we're getting from them gets better, they'll become more popular and ultimately more affordable. So.
Right. Wearable technology. That's where the industry's going, right?
Yeah, that's right. That's awesome. All right. Any other questions right now from the group? All right. We'll give Jesse a emoji clap or thumbs up. Thank you, Jesse. That's excellent.
Thanks for having me. Appreciate it.
All right. I'm going to stop the recording here.